Alright, hey guys, this video leads towards something that I call the frequency shortcut, alright? So I want you to ignore what's behind me and just copy down this 3-column table. The first column is for the harmonic number. We call the letter N the harmonic number, and you could fill in 1 for N, or 2 for N, or 3 for N, or 4 for N, depending on what harmonic you're in, 1, 2, 3, or 4. Then you're going to draw the pictures of all 4 harmonics. There are more, but 1 is the loudest one that you're going to hear from an instrument, and they get quieter and quieter even though they exist when you pluck a string on all instruments. These 4 and more are all playing at the same time, actually, and you hear multiple frequencies and pitches that all kind of harmonize together when you pluck a stringed instrument. But 1 is the loudest of all of them. Anyway, so the last column, for frequency in hertz, we're going to get to calculating that on the other side of the board. So copy that down. I'll pause. Alright, we're back. So hopefully the table is all copied down. And I want to label nodes and antinodes of all these. The antinode is the hump. It's the part that vibrates. So A. All the humps get an A. And you could see, if you count the A's, 1 A, 2 A's, 3 A's, 4 A's, you get the harmonic number. So that's how you know what harmonic you're in. Just count the humps, the antinodes. But then the nodes is something we should talk about as well. The nodes are the parts that don't vibrate. Now on a guitar or any stringed instrument, the string is locked down on both ends, here and here. Okay? So on each end, there's a node. So I want you to write those down on each end. So in each picture, give a node to each end. You don't need to write A and N for antinode node every time you draw this picture, but we're going to illustrate something this time. Alright, now where else are there nodes? That's right, there are nodes between the antinodes. So glad you said that. So every time between the antinodes, there, write an N for node. Now in each picture, I want you to count how many nodes and antinodes there are. What's that? You say you see a pattern? What is it? It's on the board already. Oh, there it is. There's always one more node than antinode. That's right. So if you're in the 4th harmonic, you have 4 antinodes, but you have 5 nodes. Oh, interesting. Very cool. So let's get to determining how to calculate frequency for each of these harmonics and then get to the frequency shortcut. Alright, first thing you need to know is you should copy down, don't copy this down yet, but above it, right here, the fundamental frequency. It's the frequency of the 1st harmonic. Write that down. And we're going to write it in this little box, too. Fundamental frequency. The 1st harmonic's frequency is called the fundamental frequency. Now let's flip the board over and see how we calculate the fundamental frequency. I made a space so we could calculate the 1st harmonic here and the 2nd harmonic here. Alright? And over here, we wrote the equation for standing waves on a string. The equation goes like this. On the left side of the equal sign is Fn. You might think that's F times N. That is not F times N. N, I'll make it even smaller. The N on this side is on the left side of the equal sign is a subscript. It modifies the F. It allows us to say, oh, are we looking at the frequency for the 1st harmonic, the 2nd harmonic, the 3rd, etc. Then we write F1 or F2 or F3, but it's not F times N on the left side, okay? Alright. N is the harmonic number. If you're in the 2nd harmonic, make N equal to 2. 3rd harmonic, make N equal to 3. I think it's written there. And we talked about F is frequency. V is the wave velocity, and the unit of that is meters per second. It's a distance over a time, kind of like miles per hour. Remember, the frequency is in hertz. And the harmonic number, that doesn't have a unit. It's just a number, like you're not going to get harmonic 0.5 or 1.5. The harmonic is 1, 2, 3, 4. They're all whole numbers for harmonic number. For string length, that's going to be measured in meters. So if you get centimeters, you got to convert it to meters. Okay? And you could do that by skipping the decimal 2 spots to the left. Alright? To go from centimeters to meters. Okay? It might come up in a lab next week, but we'll help you with that. Anyway, let's calculate the frequency for the first harmonic in an example problem. I'll throw some numbers out for you. So, because it's the first harmonic, n has to be equal to 1. The V, let's just make it 100 meters per second. Nice round number. The length, we're going to choose a length of a guitar string of 1/2 meter. Pretty regular length. 0.5 meters. Now let's use the equation. Let's calculate frequency. Should I write Fn here? No, I'm actually going to write F1. Why? Because I'm calculating the frequency for the first harmonic. On the top, where we write N times V, we're going to write 1 for N because I'm in the first harmonic. We're going to write 100 for V because we listed that here. And we're going to write 2 times L. And L was 0.5. So F1 is 1 times 100 on the top, gets us 100. And 2 times 0.5 gets us 1. 2 times 0.5. You could do that on your calculators to confirm it is 1. So the frequency in our example, not for all instruments everywhere, just in our string that we chose that's 1/2 meter long and has this wave speed through it, it has a frequency of 100 hertz. Now, if it were a tighter string, the wave speed would be a higher number. Like if I tighten the guitar, the wave speed might be 200 meters per second, and then you get a higher frequency. Alright? So now let's calculate the second harmonic for this same string. So it's going to be n equals 2 because it is the second harmonic now. N is the harmonic number. V is going to be the same because we didn't tighten the string at all. We kept it the same. We didn't tighten it, so it's the same wave speed. The length is going to be the same because it's the same string. And now let's use this equation again. And the only difference is that you're going to plug in n equals 2 instead of 1. So, well, on the left side of the equal sign as well. We're going to write F2 because we're calculating the frequency for the second harmonic. Alright? So F2, that's not F times 2, it's just the second F, second frequency. 2 for N, because it's the harmonic number, times V on the top is 100, and then 2L on the bottom, and L is 0.5. So on the top of the fraction, 2 times 100, you could do it on your calculators, and you're going to get 200. Feel free to pause at any time if you need to catch up. You could pause me as much as you want. On the bottom, 2 times 0.5 is 1. So F2 would be 200 over 1, which is 200 hertz. So what we're saying is if a string plays 100 hertz for its fundamental frequency, then its second harmonic would play 200 hertz. So the frequency heard from the second harmonic is double of the frequency from the first harmonic. Let's go back to our table that you had copied down, and let's fill in these two frequencies and see if we see a pattern. 100 hertz is F1, F2 is 200 hertz. What do you think F3 is going to be? You don't double the 200 to get the third. It doesn't work that way. Sorry, you can't use the second to get the third. I know you were thinking that, but the only way you could get the third or the fourth is not to look at the one before it, but to look back to the first one, the fundamental frequency. All right? If all the other frequencies for 3, 4, 5, 6, so on, are based on the fundamental frequency. For the second harmonic, if we double the fundamental frequency, we get the second harmonic's frequency. But for the third harmonic, that's right, you're catching on now, you have to triple the fundamental. So it's just another 100 added on in this example. For the fourth harmonic, again, it's based on the fundamental, but it's the fundamental times 4. F4 is 400 hertz. Now, if the fundamental were a different number, like 50, then the second would be double of 50, the third would be triple of 50, and the fourth would be 4 times 50. So that would be like 200. They're all based on the fundamental. Multiply the fundamental by 2, and you get the second harmonic. Multiply the fundamental by 3, and you get the third harmonic's frequency. And multiply it by 4, and you get the fourth harmonic's frequency. What do you do to get the 10th harmonic's frequency? Multiply the fundamental by 10. What do you do to get the millionth harmonic's frequency? Multiply the fundamental by 1,000,000. All right? But don't take the second and double it and think you're going to get the third. That doesn't work. What I just described is called the frequency shortcut. You can write this down, and that is the end of the video.